Hi there, this is Jacob Nash, and this is a review of Module 19. Interested in getting a headache today? We're about to have a whole bunch of different things that will seem strange. All right, Gestalt Principles. These are, the word Gestalt means whole. So this is about how we try to take pieces of information and make sense of it. Our brain doesn't like incomplete things. It's not going to just deal with, oh, I don't know what that is. It's like, let's figure out what that is. That's Gestalt principles. And there's 4 ways that we do this. Well, these are the 4 that you need to know. There's also other ones. There's like similarity. When we look at things, they're similar, but we're just going to talk about these. So figure ground. What's the main thing and what's the background? And then proximity is we group things that are close to each other. Continuity is we like continuous things better. And then closure is when we see parts, we make it a whole. 2, 3, and 4 are grouping principles, but so figuring ground. So think about what you see. Maybe post it in the comments. Tell me what you see when you see this picture. Okay, so now let's see what 2 things you possibly could have seen. People, you could have seen people or a chess piece or a vase, either one. But if it all depends on what you see as the figure or the ground. So if you chose to make the black the figure, then you saw faces. And so that means the white was the background. But if you made the white the figure and the black the background, then you probably saw a vase or a chess piece. It depends on what you think is the background and what you think is the figure. So proximity, do you see 6 lines or do you see 3 groups of 2 lines? Probably 3 groups of 2 lines. We usually like to group things that look close together. Continuity, so what do you see? Do you see a wavy line with a straight one in the middle of it, or do you see a bunch of semicircles connected? You probably see a wavy line and straight line because we like continuous things better than discontinuous things like semicircles. Closure, so do you see what's there or what isn't? You probably see a triangle that seems like it's covering up the circles, but there's no triangle there. Really what it is just 3 circles that look like Pac-Mans that just happen to be placed in a certain direction that looks like there is a triangle there. That's closure. We try to figure out what something is when it's not even there. All right, depth perception. This is just our ability to see depth. And it's tested in infants by something called a visual cliff. So they're on this kind of like glass or plexiglass table, and they're trying to go to their mom. The baby is like, I don't know if I should go there because they can tell that it looks lower down there, even though it's the same pattern. All right, monocular and binocular cues. So mono means 1, bi means 2. So it tells these mean how many eyes do you need to do these things? So you only need 1 eye to look at relative size, interposition, linear perspective, relative height, and relative motion. Here's an example and a credit to Paul Piscini, where I got this bullet list from. But look, so we can compare the relative size. Obviously, the gray ones look bigger here than there. The orange one looks bigger there than there. Actually, the orange ones are the same. But we don't need more than 1 eye to tell that. We don't need more than 1 eye to compare heights or to look at motion. We don't. All right. And then binocular, we do need both eyes for some things. So look, there's something called retinal disparity. Basically, retinal disparity is just the fact that things are slightly different in both eyes. Try closing your left eye with your right eye open and then switching. Switch back and forth, switch back and forth. You'll notice that it slightly shifts. And there's a principle that as the distance from you, as the distance of an object from you increases, the difference in your eyes' views decreases. So take both your hands and point. Now make your fingers point towards you, and you can even make them touch. and then make that close to you, right in front of your eyes, and do the same thing again, switching both eyes, only one open at a time. You'll notice that it slightly shifts to the left and right. Now make it further away. Stretch out your arms as far as they'll go. Then the view doesn't change as much. So example is like, see these two statues. If you were close to them and you did that thing where you close one eye and open one eye, then they would move. But then when you go all the way back, if you went a lot further back, then it wouldn't change as much. That's retinal disparity. All right, phi phenomenon. This is just the fact that when things move, or sorry, sometimes things look like they move when they flash. So doesn't it look like, this isn't as good of an example in my opinion because it's going pretty fast, but doesn't it kind of look like that the circles are going in around? They're just kind of going in a circle. Well, really what this is there, or it might look to you like there's a white thing that's moving, but really what it is that all of a sudden just a circle is disappearing really quick. That's phi phenomenon, when it just looks like that something's moving, but it's really just something flashing. Okay, perceptual constancies. This is just when we seem to think things are the same when they're not. So there can be color, brightness, and size. Here's the color one. Or so look at this. So obviously the background right here gets darker as it goes lower. Doesn't it look like this thing's a little bit darker at the top? Well, this thing is the same shade the whole way through. There's a color constancy here. And then over here, here's the one that really confuses me. And I bet this is going to confuse you too. Do you see the squares A and B? They're the exact same color. I did not believe it when I first thought that. Somehow they are, and I can prove it to you. I'm just going to add red rectangles to cover this, okay? They still, to me, look like they're different colors. Okay, it almost looked like A got darker a little bit. And then somehow, now they look like they're the same. Let's back that up. That's very weird, isn't it? Okay, perceptual adaptation. This is just getting used to something. That's what adaptation is, right? Getting used to a new visual field. So if you have new glasses, for example. All right, let's look at some questions. Why would it be more difficult to move with a patch over one eye? Well, this is because binocular cues help us with depth perception. And they require both eyes. I probably should have added that, I'm sorry. We need binocular cues. We need both eyes for depth perception. What are Gestalt principles used to explain? They're used to explain how figure, ground, and grouping principles contribute to our perceptions. An illusion of movement when two or more adjacent lights blink on and off in a quick succession is called phi phenomenon. Identify the four Gestalt principles, that is figure, ground, proximity, continuity, and closure. Why do people determine mountains do not shrink when they move away from them? Because of size constancy. So with the constancies, so it's when, so maybe that might have not been the best example when I was trying to say what it meant, or best definition I meant. Really what a constancy is just that we know something's the same when it doesn't look like it is. Like our eyes see it as changing, but it really isn't. So like, let's go back. That's what I'm talking about. So we know things are the same, but our eyes don't see it that way. So now you know A and B are the same, but our eyes just don't see it that way. It's just the way our eyes were made. It's the same thing with mountains. like in that example right there. Because they look like they get smaller when you go away from them, but we just know they don't because we know size constancy. What Gestalt principle is associated with reversible figures? That's figure ground. Remember, you can change what you think is figure and ground. Explain the principles of closure and continuity. Closure is what we know. We use what we know to create a whole object. Continuity is more easily perceive continuous objects instead of discontinuous ones. What is a perceptual constancy? This is just perceiving objects as consistent in shape, size, brightness, and color and illumination as retinal images change. So our retinal images are somewhat inaccurate to what really things are like. No, the mountains don't get smaller when we move away from them, but our eyes see them as they do. Identify the two monocular depth cues that are responsible for our ability to perceive objects above us. That's relative height and relative motion. I didn't really go into that much depth about that, but both of these involve us being able to see something above us because, you know, relative motion and relative height, they both we only need one eye for both of those, right? To compare. And for both of those, that an object could be above us. So like plane, for example, like we know that it is going fast, but it doesn't seem like it's going fast. So, and then retinal disparity, create an example of that. Earliest 50 feet away from 5 feet away from two statues. The difference between the images in both of his eyes is greater in this case than if he was 50 feet away. So the closer you are, the more difference there is in both your eyes. That's it for this video. Thank you for watching.